welcome back. Hopefully you were able to find your way here today. Discord has a regional outage, so let your friends know, if they don't know already, that I'll be streaming class today. So I'll take up all of class time today. I was planning to do so anyway, but I'll definitely take up all of class time now, just because you really can't work with each other right now anyway, since Discord's down. But of course, if you have some other way to collaborate, feel free to do so. Let me get rid of my face and let's look at where we last left off. Disable echo. Okay, cool. So we were finishing up the jump functionality last time and basically looking at what a pain in the butt it is to implement jumping with your, what do we call it, character controller. So implementing jumping with your character controller. So we had been working on the character controller version of moving around with the player move script here. And we'd gotten to the point when you can jump up. The getting down part is the part that we hadn't handled. So right now, if we run it, and ignore the cubes that I've added, pretend those don't exist. So if we jump now, well, that's pretty weird. And if we keep doing it, we kind of fall to the ground. Lovely. Not very sleek still. If we add a little bit more force to it, let's say, I don't know, that's too much, let's go with 15, then you'll probably lift off and fly in orbit. Yeah, bye-bye. No descent. So if you exceed gravity, you just fly off forever. Let's go to like 11 and see what happens. Bye-bye. Okay, well actually, probably notable there is that we did dip down to the ground at the end there, so there's a little up, and then when your momentum drops. So what we were calculating last time, this jump peak is basically the peak of your jump force. So when you start the jump, we're kind of gradually applying acceleration to the jump until your velocity is maxed out. And once we max out the velocity, then you're still moving upwards, but you're moving upwards less quickly, and then at some point you'll peak and you'll start coming back down. So gravity's always being added to the move, and all we have is a position delta. So we're trying to add a little bit more to the move every tick until we reach peak velocity, and then we're coming back down. So let's handle the descent next. Okay, so once you've peaked and then you've come back down, we're going to decay your, this is going to be the decay of jump force on the way down. So if your jump has peaked, which is not the actual peak height of the jump again, it's just the peak force or peak speed, you could say, of the jump. If your jump has peaked, then we are going to move you towards the ground. So plus equals, and then we'll move towards the ground. Relative to jump curve is the current state of your jump. Sausage fingered that a bunch. Okay, so this kind of plays off of what we were doing here as well. So this is if you're not jump peaked and you've not reached the peak of your curve, then you're going to travel on your way up. So we're kind of doing the opposite here. So we're going to make the curve smaller, more negative actually. Eventually it will go negative, which will actually take us back towards the ground. So always use delta time when we modify our vectors in update, and it's going to be the opposite of what we did up here. So we're decreasing the force of your jump. And this should let us have a single up and down jump now. Let's try it out. Ta-da! Ooh, that's not good. All right, let's try... oh, that is a single up and down jump. It just took us a pretty great distance. Let's try that with some different numbers. Let's try with 8. Well, that's not particularly impressive. Let's go for 10. Not bad. Look at that. 10 is a nice, smooth jump. Okay. Very nice and smooth. Now we've never changed is grounded to false, which means we can just mash the space key forever to go into orbit. That's probably not what we meant to do, right? So our next thing we're going to do is make it so that you can only jump after you've touched down on the ground again. So pretty smooth though at 10. We'll leave that at 10. You can play around with different numbers, but I'll leave that at 10. That seems to be good there. And this approach that we've done where you're peaking velocity is pretty hard to determine like what the actual peak of the jump is. So if that's important to you, like figuring out the peak y distance, that's going to be real difficult to do. Okay, so before we jump, pretty obvious, we're going to check if you are grounded. And if you are grounded, then you are not jumping. Fair play. Okay, and then obviously when you actually do hit the jump button, well, we had this is jumping and jump peak stuff, we're going to do is grounded is false here as well. So this is going to let us jump just the one time. As soon as we lift off from the ground, we are now no longer grounded, and we are flying around, and then once we touch down on the ground again, it sets us back to no longer jumping. The problem with this is that we can only jump once. Is grounded got unchecked and made it public so we can look at it. Now we can't jump again. If I check it again manually, then we can jump again. So what we really want to do is check that box when we hit the ground again. Which brings us to collision detection in Unity's collision system. We want to reset that to true when you hit the ground. Okay, and if you're still confused about the way that the jump curve and everything worked, I have a more fleshed out example if you just download this project. All right, so we want to detect when you have hit the ground. So Unity has built-in methods for detecting collision, much like update and start here. There's a few others, and they are on collision enter, on collision exit, on collision stay. The same for triggers, on trigger enter, trigger exit, and trigger stay. And then what's applicable to us today is going to be on, what is it called? Character collider hit. So what we have today is pretty special. This is the one that you're probably going to use the least, and it's the one that you only use when you have a character controller. This detects collision with the character collider. Now the other thing that you could use is the built-in, let's have a look here. I'm going to get rid of this, and I'm going to say is grounded equals, and then the built-in character controllers is grounded variable. So there's actually already a variable called is grounded, and it's part of the character controller. But what I'm going to show you, I made it public, remember, so let's play this and pay attention to the checkbox here. It is, weirdly, garbage. It's not bad for simple collision detection, and if you can see here, I'm jumping, I'm pretty happy with it. I can't jump unless I hit the ground. It's not bad, but every once in a while it just kind of whiffs that I'm touching the ground, or says that I'm touching the ground when I shouldn't be. And let me just kind of try to park my butt on top of this cube here. It's a little easier. Just kind of, okay, I'm going to get you, cube. I'm going to get you. My brain is too confused by the rotation of the game. All right. You can see I'm not jumping in some points when I felt like I was supposed to. Come on, I can make it. Let's hit this cube. There we go. Hit the cube. Let's see what happened. Is the box checked? It is. All right, so this kind of matches expectations. That's one advantage. When I jump off the cube, it unchecks it. But if that's not the desired behavior for you, well, then that's going to be a problem, because it's going to check the box when you hit anything in the scene. So if you have some objects that you want to consider to be the ground, like maybe this floating cube should be the ground, and some objects that shouldn't be the ground, then this isn't going to be suitable for you. And it has improved, in fairness to Unity, but it's not something that they've ever really paid much attention to. So built-in ground checker equals not bad, but not great. So let's write our own. Bring that back. Okay, so to write our own, we set it to false when we start the jump. That's the same thing that the built-in one does, essentially. As soon as you're not touching the ground, it sets it to false. And then we are going to have to set it to true when you hit the ground. So this triggers any time that you collide with anything. How do we make it so that it only triggers when you hit the ground? The easiest way to handle collision events with only certain kinds of targets is to use tags and layers. So let me go to the terrain real quick. And I said earlier that every object has a transform and that's it. Well, that's not entirely true. There's also one other thing that every object has, and that's the tag and the layers. And those are basically just string fields that are attached to every object that you can check. So I'm going to make a new tag. Actually, I already made this, but I could have made a new tag. If I go to add tag here, I've got my different tags that I can use, and I can just add new ones here by typing something. So I made one called terrain. And then going back to my terrain, I am going to tag the terrain as terrain. I could also use layers. Now the difference between tags and layers are more complicated. A tag is just a string, basically it's attached to every object, and you can check what it says, and that's about it. A layer actually enables you to go to your project settings, where are you? Project settings, and go to physics and decide which layers collide with which other layers. So you can make certain kinds of objects, like let's say projectiles from the player. You can make projectiles from the player ignore the player by making sure that they don't collide here. So you can uncheck the box between the player and your projectile objects, and then they won't collide with each other. You can also do some cool stuff with layers when it comes to cameras. So you can build certain cameras that only see certain layers, or some cameras don't see certain layers through masking. And this allows you to create, let's say, UI elements, like a mini-map, for example, that rests over the world view and only sees everything as colored boxes or something instead of as objects. You can have health bars display and then not display, depending on whether a camera can see the layer that the health bar is in or not. So there's all kinds of cool stuff you can do by configuring layers. Whereas tags are just a little bit simpler, basically just for grouping things together. And one of the big limitations with Unity that's been around since the beginning is that you can only give everything one tag in one layer. So you really have to plan ahead. And you might end up with a lot of tags if you don't plan ahead well. Okay, let's go back to what we were doing there, which was working on when you hit the ground, it should reset. Let me see my notes here. All right. So this hit object gives you information about the collision. You can use this to get the location of the collision and stuff, to play animations like dust coming out or whatever, but we're going to do something pretty simple here. So we're going to look at our hit, and we're going to look at the transform of the thing that you hit. So if you look at the comment, it says the transform that was hit by the controller. So hit.transform, hit.gameObject, that gets you the thing that the controller attached to this object hit. So if hit.transform, we're going to compare the tag and see if it's terrain. Spelling counts here, so hopefully I did that right. And if that's the case, then we're going to set is grounded equal to true. So very straightforward. And let's see if that is enough. Let's go to the player so we can see the status of that checkbox, and it unchecks, and then it rechecks, and then it unchecks, and then it rechecks. So it looks pretty good. Looks like we did what we sought out to do. But how about this little green cube that I've made? So this little green cube I actually also tagged as terrain. So when you jump on the little green cube, pick the character again, you should also reset that flag. But you may have noticed an issue already, which is that it resets the flag as soon as I make contact with the cube, whether or not I have hit it with my, let's say, feet or not. So I can actually just jump again as soon as I touch the cube, which enables me to like crawl up the sides of it. If you did this on purpose, this is really cool behavior for like climbing walls and stuff. It can lead to some pretty wonky effects like that there because of the manual nature of the way we did jumping, where if you can't move on the y-axis, it just kind of stutters back to the ground. But it's something that you could use to your advantage if you wanted to be able to like climb up walls and things. And it also lets me decide what objects I want to be considered ground. Now what if I hit something like this red cube, which is not tagged as terrain? Well, now I'm not grounded, so I can't jump. But I'm just kind of stuck on this red cube until I fall off, and then I just instantly hit the ground, because I've been building up velocity on the y-axis the whole time that I've been sitting on this cube. Remember, gravity keeps pulling on me, and as long as I'm not touching the ground, I just keep building up y momentum. So as soon as I walk off the edge, just plop. Not bad behavior, anyway. So that kind of brings us to the conclusion of the character controller-based way of moving around. Any questions, you'll have to post them to YouTube chat. Somebody said that I spelled terrain wrong, and you're probably right, but I probably spelled it wrong everywhere else, and that was my saving grace. Looks like it worked after all. All right, next up then, we're going to get rid of this guy, or actually, let's just copy this guy. So the best way to copy an object, if you click and go through your options here, there's a copy and a paste. You can also Control D, which is duplicate. So we'll call this player RB alt. And I'm going to get rid of this guy. I'll just remove him from the scene. Actually, let's leave him in the scene. We'll have both objects move at the same time. That's fine. So this guy, I'm going to give him a different color so we know how to tell them apart. So this guy can be teal. And I'm going to remove his character controller because that's not how we're going to move around anymore. And I'm also going to remove his movement script because that's not going to move around anymore. I'm going to give him back his capsule collider because when you use a rigid body, you need a collider. And then I'll add a rigid body to him. First, let me show you what happens if you have a rigid body without a collider. Goodbye. If it can't collide with the ground, gravity is just going to pull it into the infinitum. So that's why you need a collider. That's checked. Next, very important lesson on rigid bodies is that you don't ever want to use a mass of 1. Okay, a mass of 1 means that you can't make it any lower down the road, and you're going to be tweaking your mass as you go. So always use a mass of something big to start with. I'm going to use 150 here, but it's actually better to use something even larger than that to begin with. And then just continue on from there as you need it, more or less. Because if you make the mass too low, then you can't decrease it, and you're kind of in a rut with your physics interactions. You have to start decreasing the force or something, and that's not always easy to do. Okay, let's look very briefly at what these fields mean. So drag is how much the object's velocity slows down naturally every frame. So in a frictionless world, drag is 0, but most things don't exist in a frictionless world, so you always want to have at least some drag. But anything over like 0.01 is a lot of drag. Things will slow down very quickly. You can use really high values of drag if you want to purposefully slow the movement of a rigid body very quickly when it's not actively under force. So if your rigid body should only move when force is being applied to it, you can set the drag really high and then it'll skid to a stop very fast as soon as the force ends. But then your force needs to also overcome drag. The higher the drag is, the more force you need to add every frame to make it move. Cool, if Discord's back up for somebody, then it'll be back up for everybody else soon. It doesn't let everybody connect at the same time to stop it from being flooded. Angular drag is the same thing as drag, but for rotation. So if your object's spinning, well, eventually it's going to spin to a stop, right? And angular drag determines how long it takes before it spins to a stop. So if it's 0 and you set the object spinning, it'll just spin forever, like a sphere spinning in frictionless vacuum suspended in nothing. But that's, again, not how most things spin. There is some friction whenever you spin. Use gravity is pretty self-explanatory. You can get rid of it if you don't want the rigid body to be affected by gravity. Is kinematic is a very interesting one that we'll go into in more detail, but it essentially means that the object does not actually have physics interactions, but it can still collide with other things. So we'll go through the table of what can collide with what later, but kinematic rigid bodies are going to be very important for certain applications, something to keep in mind. And then we'll look at collision detection a bit later. Interpolate you're probably not going to touch, and honestly it doesn't matter. And then we'll look at constraints in a little bit too. Okay, so let's start a new script for moving this guy. I'm going to call this player move RB alt. So remember, everything that I am remaking that I made earlier is going to be alt, so you can just look at the original version if you want the one that's better with more comments and feedback and whatnot. So clean that up. Let me pull up the original in my notes. Okay, so the first thing we're going to want to do is grab the rigid body so that we can interact with it. I'm going to use the get component approach for simplicity, so we'll call this get component rigid body so that we can link to it. Lovely. Okay, let's also add this script to the player controller. And there we go. All right. Now let's try moving it around based on the position of the sticks. So we're going to do stick X, input dot get axis horizontal. Do the same thing for the other stick. Vertical, cool. So that's the position of both sticks. Let's go with the vector that we're going to move in. And we'll just make that the stick positions for now. I'm going to show you a little bit later how to move in a more complicated way, because something you might have noticed right now in both the rigid body version we're about to make here and the character controller version we made previously is that all of your movement is relative to world space. And if you don't have a fixed camera like this one that just sits in one place the whole time, well, what happens to your movements? If I was to move the camera around, let's say I rotated it, whoops, wrong way. I rotated it like that. Well, forward isn't forward anymore. Forward continues to be that way, forward relative to world space. And so now the camera is inaccurate relative to my controls. And actually, you can kind of play games that are built like this because the human brain adjusts to it pretty fast, but it's not ideal. You want forward to always be forward relative to the camera. That's the way most games are. So we'll look at how to do that after we're done with the rigid body movement, if I don't forget. Okay, so I applied that to move, but I actually haven't applied any force. So there's a couple of ways that you can move a rigid body. The worst way, and the way that you should pretty much never use, but the way that's described in many tutorials on the internet, unfortunately. And let's make a move speed so we can vary this up, is to set the velocity of the rigid body directly. And I'm going to divide this because when you set the velocity it's a lot, and I'm going to have a different value. So let's go with time delta time. I'm going to use the same value when we do it the right way. Okay, so let's see why that's crappy. First I need to set a move speed. Let's see what I used. I'm going to cheat a little and see what I used before. I used a huge number, 10,000. You see big numbers when you're playing with force, by the way, and don't worry about numbers with lots and lots of zeros. You have objects that you're moving around with rigid body force, you're going to see big numbers. That's just the way it is. All right, so here we go. Are you ready? In fact, let's maximize this for maximum effect. Let's go. Dun, da, da, da. Oh boy. Oh boy. That's, yeah. Yeah, well, he's moving. Look, he's floating. And he's got angular momentum. Well, if this was the kind of game you wanted, then you've got it. And now I can make it up the hill by just kind of... this is just me holding the arrow keys in one direction, by the way, not doing anything fancy. Also notice I'm no longer affected by gravity. Why? Because I set the velocity manually. And if you set the velocity manually, well, no more gravity for you because you set that component to 0 because your velocity on the y-axis is 0. Okay, well we can make that a little bit better. We can do a little bit better with velocity. Let's do slightly better than that. So we're going to do the same thing, but we're going to at least preserve your velocity on the y-axis. Okay, so let's do, we're going to take your velocity on the x-axis, and we're going to take your velocity on the y-axis as whatever it was. Whoops, not render buffer. rb.velocity.y. So we'll preserve your velocity on the y-axis. And did I miss the delta here? Yeah. So we'll take your movement speed on z and x, but we'll preserve your velocity on the y-axis. All right, so that's a little bit of an improvement. Let's see what that looks like. And now, at least, I'm affected by gravity, but boy, do I still look pretty funny, don't I? But I can kind of roll my way to wherever I want to go. And if you were making Goat Simulator or Katamari Damacy or something, I guess this would probably be your stopping point, because that's basically how you move in those games anyway. Perfect. If a rolling ball that just comically rolls through its environment is what you were going for, we're there. Sweet. All right, but let's say a rolling ball that comically rolls through its environment is not what you were going for. And let me back up to some questions. So if you're having problems importing the example that I put up, it's probably because you have a mismatch Unity version. So I have 2023 26 F1. Otherwise, feel free to post the script errors to Discord when it comes back, and I'll have a look at them and see why it might not be importing. Somebody else asked if the script has access to the player. Since it's a component of that player, it can access other game objects. So any script could access other game objects by linking them in the inspector. So what's an example of a script we had? So far we haven't had any scripts that linked objects in the inspector, but you could make a public game object something else, and you can then in the inspector link this to whatever you want. So let's say I wanted to talk to the cube for whatever reason, I could link that there. And that's how you address other objects within your script. But the rigid body and everything that it's getting when I use getComponent, and in the character version when I was getting the controller collider hit, when I was getting the controller, all of that stuff, it's looking in the game object that the script is also attached to. So since I had the rigid body attached to the same object as this script, they're both components of the same object, the script can easily find the other attached component. And remember that if they're not attached to the same object, there's other options too. There's getComponent in children and getComponent in parent as well, which I should note you should usually avoid because they're expensive. It's easier to link the object directly in the inspector, the thing that you're concerned about. And perhaps most importantly, those scripts stop when they run into the first object of the type that you're looking for, unless you use the array version, which gets even more complicated. So hopefully that answers your question. Let me know if it doesn't. All right, so these were the two crappy ways to move because they set the velocity manually. And when you set the velocity manually, you miss out on the ability to do a lot. You can no longer ragdoll this object. You can no longer apply force to it because every frame you're changing its velocity. That's no fun. So basically, don't do this unless this is strictly all you want, and you have no other plans to have your object affected by other forces beyond being able to move like this. So that brings us to the right way to do it, which is to add force in the direction that you want. All right, so instead of just setting the velocity, we're going to add force on the vector that we want to move, proportional to the move speed. This is why I divided by 100 in the earlier examples, because you actually have to add a lot of force to move something that has a mass of 150. Setting its velocity ignores its mass too, right? Because you're just giving it speed. Whereas here, the more massive it is, the slower it's going to move. Okay, and then always timed at delta time, even when you're applying forces. If you're doing it in update, always got to have that time delta time. All right, so let's see what this looks like and if it's a little bit more natural. Notice I didn't have to preserve the y-axis there because I'm always only adding force on z and x. And this looks about the same, still equally goofy. But if you really look closely, it's a little more smooth. I can do some cooler stuff now. I can roll up this hill maybe like a champion. It'll take me some build up. There we go. And I'm handling those slopes a lot better. Maybe let me maximize it and really show off how great this movement is. Obviously the red guy's still moving. You can see kind of what keys I'm pressing based on the red guy's movements. Let me see if I can clear this slope. Almost did it. Okay, but let's get a little bit more serious. Let's think about how we can keep our character upright and not toppling over and rolling around like a dummy. Well, that's where the constraints come in. And using constraints is kind of like cheating. A better approach sometimes is to just turn your character into something that doesn't flip. But if you think about most RPG titles, most games that have like an upright character that moves around, and this includes you guys who are thinking of maybe top-down games and stuff like that. Generally speaking, your character doesn't have the ability to flip over. So I'm going to constrain our rotation on X first and see what happens. Well, I'm still able to roll that way, and that way, and that way. So really no noticeable difference. The only way to completely keep you from flipping is to constrain your rotation in both dimensions, X and Z. So you're still going to be able to turn. We'll do that later, but I still want you to be able to face the way that you're moving like our character controller did. But now you are no longer able to flip. And we'll notice that now that you're not able to flip, you kind of spin funnily in certain situations because force pushes you that way. We'll work that out in a bit and change that. And it's also harder to clear hills now that you don't just roll casually over them, which is probably for the best, frankly. All right, so we no longer flip over. The next step is for us to be able to rotate around in the direction that we're actually facing instead of just spinning randomly when we hit things. Okay, so the easiest way to rotate is to affect the transform directly, which is, it's not great, and it's bad practice to affect the transform directly. It's better to handle everything with force when we're dealing with rigid bodies, but that's really hard to do. So if we want you to approximately face the direction that you're moving, well, we want to rotate around up relative to the world. So if you think about the direction that you're facing with your little outstretched, goofy zombie hands, we're actually rotating around this green axis. And then we're determining which direction you want to face relative to your rotation around that green axis. So we're going to rotate around the green axis, and we're going to go towards the stick X. We'll see how that works. And I'll actually add a rotation speed variable so we can play around with that. What else do we need to do here? Multiply by our rotation speed, and then as always, delta time. Okay, and let's set that rotation speed to something. Let's see what I used as a good value before. I used 10. Alright, so 10 is a good value. And I'm rotating very slowly. And I still kind of rotate funnily occasionally. Let's see. Okay, well, that doesn't work great, does it? So, did I miss something? Do I have the speed set? 10, I used 10 before and it worked okay. Let me try cranking the speed up to, let's say, 50. Let's see if I get better rotation that way. Still kind of slow. What if I did 500? There we go, except I just kind of shoot straight past. So when I hold down A, I just spin in place. When I hold down D, I just spin in place. When I move forward and use A and D, I can kind of work it out, but not really great. So before we move further with it, I'm going to return it to 10. Let me point out that we're actually doing some pretty bad things here. And the bad thing that we're doing is that we're trying to affect physics inside of update. And while this isn't really the worst thing you can do, what you really want to do when you're affecting force is apply force consistently, not determining based on how many frames have gone by of display, because update is how many frames have been rendered to the screen, but actually based on how many times the physics engine has ticked. And so there's a separate method called fixed update that fires off once every time the physics engine ticks. This is a fixed frame rate. And if we move all of our stuff in there, pretty much works the same. The only thing that we're going to have to change is that instead of time, delta time, we're going to use fixed delta time. Whoops. And I'll fix my commented out ones as well. Okay. Fixed delta time. And let's see if that actually smooths out the motion a little bit. Well, I can clear hills now a little bit. And everything generally moves a little bit slower, or not a little bit slower, a little bit more smoothly when you process your physics inside of fixed update that way. Alright, let me get that rotation down first. So it looks like I didn't give myself a good placeholder number, so I'll have to figure one out. Transform up, stick X, rotation speed. Okay, let's not maximize. We'll pick our guy, and I'll just play around until I find a number I like. Let's go with 150. It's a little slow. Let's go with 200. That's not bad. 250. Whee! Look at me go. One way that I might be able to make the spinning in place thing better is by giving my guy more angular drag, then he won't quite spin in place for so long, and the rotation that I actually apply to him is more meaningful. 250 is too big. Let's go with 150. Maybe a little more angular drag is good for you. Okay, it's not great, but I'm happy with it. Let's go with 150 and 0.5. What did I do earlier? 0.05 and 10. Well, I guess I'll keep it at 0.05. All right. Let's see, anything else for force-based movement before we go on to facing the camera and stuff? Let's do jumping, because we did jumping in our character controller version, so let's have a void jump. Give you a little example of methods. Okay. All right. So let's say that we want to jump. We're going to do if inputs dot get button down jump. Then, and then let's do the same thing we did earlier where we had an isGrounded method. Or an isGrounded field, sorry. So try to bool isGrounded. True by default. I'll make it public too so we can see the check mark go on and off. I'm not going to set it, but just keep it like that. Okay, so if you jumped and you are grounded, then adding force to a rigid body is dead easy, and that's all we have to do when you jump. Let's actually make another field for the amount of force that you get. We'll call it jump force. And the higher you set the jump force, the higher you jump. All we have to do to make a rigid body jump is add a bunch of acceleration to it on the y-axis at the point of origin. So jumping is dead easy. And we can move all of this business into our jump method if we want. So we'll call this jump at the end here. And of course, when you jump, you are no longer grounded, so we'll have to deal with the collision on the ground on the way back down. But let's set the jump force and see if this works. So what did I use before as a good jump force? I used pretty much the same I used for move speed. Cool, let's do that. So jump force of 10 kajillion. There we go. Move over there, move over there. I can now turn the way I want. That's cool. And I can also move left and right while I'm turning. I still have that issue where if I continue moving to the left, eventually I'll just spin. But hey, that's fine. And now let's jump and look at what happens to the checkbox. Nothing. Nothing's happening. But if I keep mashing the space bar, it works. Let me check that box again. Okay, it worked that time. Try again. Spacebar, nothing happened. Spacebar, nothing happened, nothing happened, nothing happened. And the reason nothing's happening is because I'm trying to get a button input inside of fixed update. Fixed update fires at fixed intervals when the physics engine ticks. If you're getting input that needs to be gotten quickly, so if you're getting a button down or something, all of that stuff needs to happen inside of regular update. So while you want to do your physics stuff inside fixed update as much as possible, when you're doing one-time physics events like this, those will have to happen inside of update because they're in response to user input, and user input is best gotten inside of update. It's bothering me that that function's not capitalized. So let's try that out and see if it's more responsive. Boom. It is indeed. And no messing around with jump curves, no playing around with craziness. I was just able to do this by adding some force, and no big deal. And if I cut that force in half or whatever, I can get a jump that's half the height, so I'm able to really flexibly determine how high my character can jump and all that good stuff. Now let's handle collisions. So I want to collide with the terrain again, and restore is grounded when you collide with the terrain. So for objects that have a rigid body attached to them and have regular physics-based collision, we're going to use mostly on-collision enter and on-collision exit. And you notice you get a different object here. Instead, you get a collision. It works pretty much the same way as a character collision. We want to see if the collisions attached transform, the thing that we ran into, is terrain. Then we're going to set is grounded true. Okay, and let's see if we can now jump as much as we want. And I'll turn down our jump height a little bit because I think we were flying a little too close to the sun there. Okay. Let's go. Whee! Spin, spin, spin. Now, one thing you'll notice about our rigid body based guy versus our character controller based guy is the difference in smoothness of motion. The rigid body based guy, when I'm moving, this is me just moving up and down, he moves slow and then fast. He actually builds up momentum as he goes. So you could say he's a little bit more boaty. He has inertia. It takes him a while to get up to speed. We tried to emulate this effect a little bit on the character controller by slowing him down when he's not facing the direction he's moving, but it was tough, right? And likewise, it's tough to do any kind of slowdowns, whereas for the rigid body, it's very natural. And so he's kind of just, boop, also responsive to collisions. When our character controller guy runs into him, which is kind of hard to do because they're both controlled by the same buttons, he gets ricocheted. He flies away, depending on how much force he gets struck with. It's kind of hard to see this. You have to really build up some momentum to whack into him. There we go. He got deflected there again. Boom. Whereas our character controller guy has no ragdoll whatsoever. He doesn't get affected at all. So if that's the desired effect, if you don't want any kind of ragdoll or response to physics on your main character, you're going to go with the character controller. Whereas if you want a little bit of physics on your main character, like our rigid body based dude here, then you're going to want a rigid body. Let's try again. Get some nice force and really whack him. There we go. Got a nice deflection. Really whack him again. It's hard when they move with the same buttons. Yeah, alright, great. When it comes to jumping, well, it's clear that the rigid body one is more natural. The red one, even with the jump curve and everything, it still looks a little bit unnatural. We still had to make some fudging calculations there. We haven't gotten our rigid body guy to face the direction that he's looking at yet. And we also have to deal with this annoying problem when we use the rigid body of dealing with this angular momentum. We had to freeze it on 2 axes. So there was some extra stuff that we had to deal with there, and it's a little more difficult for us to determine which way he's going to be looking at. But you get a lot more smoothness from inertia. There's a lot of advantages. So it's up to you which kind of control is more fitting for you in your game. Most humanoid, lifelike characters will probably be happier with the character controller. Vehicles, planes, boats, or anything that needs to respond to physics might be happier with the rigid body controller. But think about it and decide what's right for you. Okay, let's try. We'll start with the physics-based one. We'll start with the rigid body-based one, and we will move in the direction of the camera instead of just moving in the direction of world space. And to start with that, we're going to get the camera to move around first. So let me pull up my notes. Let's make a new camera. It's camera, and this is going to be a camera rotates around player alt, because I already had made one earlier. Now, you can only have one main camera in your scene at a time, so when you have more than one, Unity gets kind of confused and just picks the one that it wants to be your main camera, and well, that can be annoying, so just turn off your other cameras so that only one camera can be the main camera at a time. I'll kind of decide where this camera starts, although it actually doesn't matter because we're going to control all of its movement programmatically. Okay, we'll make a new script. This will be follow camera alt. And here we can practice some of that referencing other objects. We're going to actually have to have a link to the player in order to figure out where we're going to be. Now, this is going to be one of the harder scenarios. This is going to be the camera rotating around the player as if you're in kind of an RPG style game, and we're going to use the mouse to rotate, or the right stick on the controller, so they share the same input. So we have the thing that we're trying to follow, which is the player, probably. Someone asked if we can swap between cameras. Yes, that's as easy as setting one camera to active and another camera to inactive. So if you had a reference to the other camera, let's say the other camera was to follow, then we could simply set it to being active. Unity will pick it up as the main camera once it's set to active, and we'll set our current camera to inactive. And that allows us to swap between different views. So it's easy to swap between which camera is main. If you have multiple cameras active in the scene at once, you can do this to make like mini-maps or alternate views of your character. You can also swap between which of those is the main camera. It's also possible to do. So we'll do rotation speed and how far away you want the camera to follow you from. And then I'm going to need a couple of placeholder variables to use globally. And I'll make, well, I'm just going to do one offset actually. You can see what a zoom camera looks like in the example, but the math is a little too complicated to go over here quickly. First, let's look at some other features that you get with cameras too, beyond, I'm going to use the position to just determine how far away the camera is going to be, but there are other ways to make the camera see different things. You can adjust the field of view, which makes things look like they're closer or further away. But if you look at the camera here from this perspective, you can see that when we adjust the field of view, we're actually just adjusting the width of the box that it sees. And this kind of closer or further away stuff is an optical illusion that results from that. The clipping plane determines how close an object has to be or how far away before the camera just doesn't see it anymore. It just vanishes from the camera field of view and becomes transparent. The Skybox determines what the camera sees when it looks beyond the limits of your application. So if you are looking at the horizon, obviously it goes off into infinity. The Skybox is what your camera sees when it looks out into infinity. You can change this to just be a color, for example. Now look, we're just seeing a solid color as you go off to infinity, or a Skybox, up to you. And then culling mask is to determine what kind of stuff you can see, so we can kind of turn off certain things, and this is more complicated. You probably won't touch it. All right. Oh, you can also change the kind of camera you have. So many top-down games don't have this kind of conical natural view. They use what's called an orthographic view. An orthographic view, as you can see, is a square camera. These cameras are usually best put directly overhead for top-down games. And so you might recognize this view from many popular top-down games. The same view from a perspective camera looks just a little distorted. Everything seems like kind of out of view. An orthographic camera lets you get really square, consistent, planar views from top down. So most of you will probably use a perspective camera. Where I want it to start. You probably won't touch that. All right, on to getting the camera to follow the player. So how far away you want to be, that's going to be determined by the object that you're following, and then plus some distance away. So we're going to go the distance away on the z-axis, and we're also going to have the camera float up a bit. So I'm going to call it like, I don't know, let's say 7 units high, and then how far away it is going to be determined by follow distance. Okay, and then on update, we're just going to set the camera's transform because we don't want it to react to physics or anything. So this is one of the rare situations where we do actually want to affect the camera's transform directly. First, we want to get the mouse's position. A mouse is an axis from -1 to 1. We're going to get mouse x, and we'll get the mouse y, and we can use this. Actually, we're only going to move with x and y for now, so we don't even need that, to move our little guy around. So here's going to be the most complicated part of this. What I want when I'm moving the camera around is I want, relative to the player's vertical axis, okay, I want an angle on this circle that you can imagine around the player. I want the camera to be a fixed distance away from the player, but somewhere on this circle relative to the vertical axis. And so for that, I can use angle axis, which gives me a rotation that's angle degrees around an axis. So if you think of the axis I'm trying to rotate around as the transform's vertical, I want an angle that's some degrees. So some degrees around this circle. Angle axis relative to the mouse, the rotation speed, and again towards up, or I could use transform up. We'll see the difference there. It depends on whether or not you want to account for movements in the character. Usually you don't. And this is proportional to that distance that I want to be at, so however far away I want to be at the end of the day. Okay. And then I'm going to set the camera's position to the player, plus that offset that we calculated using that imaginary circle around the player. And then I'm going to have the camera look at the player directly. So I always want them looking directly at the player, and I don't want to slurp towards the player or anything. I want it to be instantaneous. All right, let's see what this looks like. So I'm going to first link together my camera and my player. So I want to drag the follow script onto the camera. And then I want to link my player to it. I'm going to use the character controller player first. And I'll set the rotation speed to something. Again, I'm going to cheat. I used 20 and a follow distance of 8, so I'll do the same thing. That determines how fast it reacts to my mouse. I could also include delta time here. I probably should, but then I have to figure out the new rotation speed, so let's just leave that for later. I should probably include delta time. On the other hand, you might not. If the computer hiccups and you run out of frames briefly, you still want the camera to resume in the right place, right? So there we go. Okay, and now I can rotate around my player, and you see that my movement is quite defective. If I hold down W, I move relative to true world space. That's not what I want. I want to move relative to local space. And actually, right now, my camera is orbiting around nothingness. That's not right. Let me see here. What did I do? Oh, I wanted to add the actual character controller thing that moves around. It should orbit around that, not the child of it. Is that better? Yep, there we go. Now I follow it. Okay. And I can kind of, again, figure it out, but left and right get really confusing when they're relative to the world rather than to my character. So let's go back and fix that. Let's make left and right relative to the character rather than to the world. Okay, so when I first, remember this is my script for controlling the character controller. When I first started calculating the amount that you should move, I scaled it relative to just the sticks directly. I didn't do anything to modify it. So what I'm actually going to do is I'm going to scale it to the character's transform forward and transform left and right. How do I do that? Well, to move equals, and then we're going to do the sticks X. Yes, so X is going to control how much we move left and right, and then our forward is going to be controlled by the stick Y. And it really is as easy as that, because these are, these are both vectors, and we can add vectors together. And then we can scale vectors relative to some magnitude. In this case, we're scaling it relative to the amount that you've held down the analog stick, or if you've held down WASD. So we're just scaling relative to transform right, the amount that you've held down left and right, and scaling relative to transform forward, the amount that you've held down Z. So let me comment the original out. Use this instead. Let's see what the difference is. Although for you, it doesn't really look that different. For me, it's way different. Now, forward is going to be forward, and left and right are going to be left and right. And I think I have them backwards right now. Do I? Nope, I don't. Okay, great. So forward is actually forward, and left and right are left and right, and I can move around the world freely. Whee! Wow, my jump is off. Okay, so I'm going to have to tweak that jump curve now that I've adjusted all of this. Again, pretty annoying to work with. Character controllers. Okay, let's do the same fix, but for the rigid body. So I'll add that guy to my to follow camera instead. Should I have a different name? Okay, so I've added that guy to my fixed camera instead. Let me go back and patch up his script. And that's this here. And I'm going to do the same thing. I'm going to move relative to X and Y. Let me actually just copy and paste it. Let's try doing the same thing that I did earlier and see if it works out. Okay, my camera's now orbiting around this guy, and let's see what happens when I try to move him forward and around and stuff. Well, works pretty well. I can move left and right. I just kind of spin still. I can move up and down. Movement is relative to my guy, except that, well, it's still kind of wonky. Right now I'm trying to move forward, and I am, but well, my guy just kind of faces random directions as he goes, so it's not particularly easy. What you actually want when you're moving a character, let me play it again, is if I held the back button right now, I would want him to move towards me, and that's great. But if I held the back button right now, which way do I want him to go? I want him to go towards me. I don't want him to go back relative towards himself. I want him to go back relative to the camera. Okay, so that presents us with another option. We want to move actually relative to the camera. How do we move relative to the camera instead of relative to the object space? So we did moving relative to the world, we did moving relative to the object itself, so its own transform forward and right. Now let's do moving relative to the camera, which is probably the most useful if you're doing some kind of third-person RPG type game. Okay, well for that we need access to the camera, and if we need access to the camera then we need to have it defined as a game object, or we probably only need its transform in this situation. We don't need anything else attached to it, so we'll just use the transform of it, and I'll call this the compass, because this is determining the true direction that left, right, up, and down are always going to be relative to. Okay, and let me try, get rid of these commented out ones. Let's try to move equals stick Z times true compass forward. We did that earlier. And let's try adding the stick X, and we'll see what happens when we get rid of it. So I'll have it on 2 lines this time, but it means the same thing. So forward and right. Okay, I'm going to go into the script here and add our camera that rotates around the player as the true compass. And let's see how that looks. Alright, so when I mash forward here, nothing happens. If I mash back, he does move back. Why doesn't he move forward when I hit forward? Well, he does move left and right, so that did work. and he can move back pretty quick, and if I rotate the camera, I can just kind of move him back in different ways. The problem is that I'm using an object that's at a slant as my true compass, so if I look when I'm playing the game at where the camera's at, as I rotate, the camera's above me, and it's transformed forward. This blue line kind of leads directly into the ground, so if you apply force on the camera's transformed forward now, you're just applying force towards the ground, and that's why forward doesn't really move you anywhere unless you bumped up the force a lot. Let's say I bumped up the move speed by a factor of 10, then I could probably inch my way forward a little. Let's see. There we go. Managed to inch my way forward a little, but now if I even tap that back button, I'm going into orbit. And you'll notice that I moved again towards the camera when I tap that back button. When I tap back, I move the opposite of transform forward, which is along this blue axis. So watch, when I tap back, I'll fly along the blue axis. So that's not what I want. I actually want the point that's just under the camera when I'm playing, that's basically at ground level. I want to move relative to that. So that's where the true compass is supposed to be. Okay, so one way, a kind of a simple way to do that, which is what I did in the example, is to attach a child to the camera. That's the true compass, and it's grounded relative to the camera. So let's try that out. Let's create an empty game object. This is going to be the compass, and I'm going to see where the camera's at when I'm playing, and then I'm going to ground that thing relative to the camera. So here's where the true compass is at. I'm just going to scoot it down here. And then I also want to make sure that its rotation is true relative to world space 2. So with the camera that I've got now, it looks like -60 gets me back to flat. This is going to vary depending on what I picked for that offset, right? So I could have calculated this with some fancy math, or I can just do it by hand, which I chose to do instead. And now the blue axis is actually where I want to move. So if I was to push forward right now, I would want to move relative to the blue axis we're looking at now. If I was to push right, I'd actually want to move right relative to the blue axis I'm looking at now. So I got to remember these numbers. It's at -6, 7, -60. And then I'm going to stop and actually put it there. So -6, 7, and -60. Let's play again and see if it's in the right place. And yep, there it is. It's at ground level. And now I will change my character's compass to that. And now I'm applying force relative to this imaginary thing that's on the floor attached to the camera, and I'm actually moving in the direction of the camera when I want to be. And it's super easy to move around, and everything is great. And I can move up hills, and I can jump, and I can do all that great stuff too. So this is the most natural, probably, movement that you can get. Let's see, what else do we have? Any questions, actually, before we move on to something else? Didn't think it would take us quite this long to do motion, so I don't think we have enough time to start spawning game objects and stuff. But I guess I would like to mention a little bit about instantiation, so some of you can get started, because some of you have already moved on to that point. So let's talk a little bit about instantiation while we can. Let's see, what's a quick route for me to do that? I'll just do it through jump. Alright, so I'm going to make a game object here. I'll call it to spawn. Alright, and I have this little cube in my scene, this little red cube. It has a script attached to it, but don't think about it too much right now. We'll go over that later. Let's say I want to spawn one of these cubes beneath my feet every time I jump. So I've created a folder here called prefabs. Prefabs are templates for objects that you can instantiate whenever you want. And anything that you're going to make more than one of in your scene is ultimately going to be a prefab. You can make something a prefab by just dragging it into your assets. So I always like to keep all my prefabs in one folder, and then usually subfolders for those for the different kinds of things they are. But once I've made this cube in my scene and I have it the way I want it, I can just drag it into my assets and it becomes a prefab. And if I double click it here, it takes me to this sceneless area where I can edit different properties about it. Because as this is just a template, every single living cube that's made will get spawned with these characteristics that you see here, exactly the way that you see them. Except you're going to have to pick the transform position and rotation as you instantiate it. And so when I attach that, I'm going to delete it from my scene. When I attach that prefab to my script, so here I have that toSpawn thing, I actually want to attach it out of my assets here, rather than out of the scene. And this tells it to use the prefab. You see this little blue cube that pops up, that means I'm using a prefab. So now let's create something at my feet every time that I jump. So I'm going to create something, I'll call it created. To create an object from a prefab, you want to use instantiate. Instantiate needs a few arguments. First, you want to say where you're going to instantiate it. Well, I want to put it at your feet, so we'll go with the position that you're at now. Just really like the middle of your body, but we'll roll with it because we're running out of time. And then you want to say, well, what rotation do you want it at? And well, I don't care. Let's go with quaternion identity. Let's go with no rotation at all. And oh, I forgot the obvious argument, that what do you want to make? So I want to spawn the toSpawn thingy that I designated at the transforms position and with quaternion identity. I could also inherit the transforms rotation by using transform.rotation. Try that out. There we go. And I set a variable for it because if you want to do anything with it after instantiating it, you're obviously going to have access to it. So this is going to be the typical way you do it. But if you actually don't care, then you can just instantiate it like this. And on the other end of instantiation is destruction, which is when you want to get rid of a game object. So let's say that I want these cubes to last 5 seconds from when they're born. Destroy takes an object as an argument, and then the amount of time that you want it to live. So after 5 seconds, that cube will be destroyed. And let's play around with this and see what that looks like. As I hippity hop, I leave this cube behind. Because I'm a rigid body, pooping out the cube actually also shoves me away, which is a great mechanic that you wouldn't get with the character controller version. And then after 5 seconds, the cube vanishes, it's destroyed. So I jump, it makes a cube, and then after 5 seconds, the cubes are destroyed. And this is a pretty funny effect because the cube, again, I'm a rigid body, so it actually blocks my way as it spawns and makes me unable to jump properly. Great. And now I'm stuck because it's pushed me into a wall. Alright, so most game object creation and destruction will happen with these two approaches. You'll instantiate things and then you'll destroy them. Something to note as you get started with maybe making projectiles or other things is that most things should have a lifetime if they have the potential to fly off the edge of the scene. So if you're making bullets and things like that, call destroy right as they're born and give those a maximum lifetime, 10 or 20 seconds, so that in the event that they disappear and they're no longer needed, they should automatically get cleaned up. Alright, I think that's a good stopping point for today. Next time we'll look at more instantiation stuff, making bullets, making them fly towards the thing that you want them to fly towards, and a couple of animation effects, spawning animations, playing them, that kind of thing. But yeah, that's a good stopping point. So let me know if you have any questions in Discord, and I'm going to pop in a Discord if anybody wants to talk about their project some more as well. So, alright, get rid of this cube spawner for now. Definitely don't want that. See you next time.